A boy drops a ball of mass 0.50 kilogram. Okay, beta. So what is this, beta? This is the mass of the ball, right? A distance of 1.1 meters. So this is basically the height from which the ball is dropped. Beta, ignore the air resistance throughout this question. So we have to ignore the air resistance throughout this question. Okay. Calculate the decrease in gravitational potential energy of the ball as it falls through 1.1 meter. So beta, we know
mgh, so that is 0.5 into 10 to 1.1, which is 5.5 joules.
Very good, beta. Shabash. mgh. Mass of the ball is 0.50. Value of g is 10. H is 1.1. Okay. So beta, then if you solve this, what answer do you get?
5.5 joules.
So beta, it's 5.5 joules. Clear, beta? Is this clear to everyone? Now, beta, the ball bounces and only rises to a height of 0.80 meter. Now, beta, after the ball bounces, it rises to a height of 0.80 meter only, right? Calculate the energy lost during the bounce. Now, beta, if the ball rises to 0.80 meter, it means what will be its potential energy there? It would be 0.50 times 10 times 0.80. Right, beta? Right or no? And beta, what is the answer? The answer is Shabash, beta. Beta Shabash, what will be the answer to this?
Sir, 4 joules.
It is 4.0 joules, right? Now, beta, when the ball bounces to 0.10 meter, it has 4 joules of energy, right? It means then how much energy is lost?
Sir, 1.5.
It's 5.5 by 4.0. So that is energy lost. So energy lost is equal to 1.5 joules. Clear, beta?
Yes.
Beta, suggest a reason why the energy is lost during the bounce.
Sir, it is converted to other types of energy like heat energy and...
Yeah, beta, but you have to be specific. Sometimes, if you write converted into other forms of energy, that's very vague answer and you will not get the marks for that. Okay. So basically what happens, it is converted into other forms of energy. That's right, but you have to write, a particular answer. Okay, beta.
Okay.
So beta, why? So you can say energy, or beta, in internal energy of the ball, or you can say the internal energy of the ground increases, right? Got it or not? Understood, beta?
Yes, sir. Understood, sir.
So beta, you can say heat heat generated in the ball, okay, or you can say the ground, ball or ground.
So there can also be sound energy.
जी बेटा?
Sound energy.
Beta, sound, it's a bounce. Usually there is not much sound, so it can be, but I think here in this case, sound is not like very, you can say, significant.
Okay.
Okay, beta. because if this is, sometimes the sound is not that much, right? And in the question this is the ball bounces and only rises to, I think so in this case we should tell this, right?
Yes.
Okay, now beta, on another occasion, the boy throws the ball down from a height of 1.1 meter. See, the ball is dropped from 1.1 meter, giving it initial kinetic energy of 9.0 joules. Now the ball is given initial kinetic energy of 9.0 joule, right? Beta, but when the ball drops for 1.1 meter, we know what is the energy it has, how much potential energy it loses. We calculated that, right or wrong?
Yes, sir.
So beta, if it when it falls from 1.1 meter high, the potential energy it has is 5.5 joule at that height, right? Okay, and beta, it is further given 9 joules of kinetic energy. So beta, we have to calculate the speed at which the ball hits the ground. So beta, what will be the total energy of the ball or total kinetic energy of the ball? Because when the ball is dropped from 1.1 meter high, the potential energy which we have calculated already, we know that potential energy, how much potential energy it loses? 5.5, right?
Yes, sir. Sir, we use the formula half mv square
But
kinetic energy.
better, but what is the kinetic energy? First of all, you should know what is the kinetic energy of the ball at the impact. जी बेटा. So beta, kinetic energy of the ball at the impact is how much?
Sir, 5.5.
No beta,
9.
it's 5.5 joule because it is dropped from 1.1 meter height. Plus beta, it is also given 9 joules of kinetic energy. So the total energy it had at the impact, or kinetic energy it has at the impact, is 5.5 plus 9.0. So what will be the answer?
14.5.
And Shabash, since we have to find the speed, so we will use, we know kinetic energy is equal to half mv square, that is equal to 14.4. Now beta, simply solve this question. 1 by 2 times, we know mass is 0.50 times v square is equal to 14.4. Now beta, if you solve this, there are two ways. First, you can solve it 0.50 multiplied by 1 by 2. You solve this, what answer do you get? What answer do you get, beta?
Sir, 0.25.
0.25 into v square, right? That is equal to 14.4. Now v square is equal to 14.4 divided by 0.25. When you do this, beta, what
Sir,
answer
it's
do you get?
14.5.
57.6.
Ji beta?
It's
57.6.
14.5, not 14.4.
Okay, sorry, my mistake, beta. It's 14.5. You're right.
So then we get 58.
14.5, 14.5, 14.5, 14.5. So beta, we get what? V square is equal
58
to
meters per second.
8.
50.
And
No
sir,
beta, this is V square. We have to find
Oh,
speed. So we'll take the square root.
7.62.
So beta will get 7 point. If we write the answer to two significant figures, we can write 7.6 meters per second. Ji beta, clear?
yes, sir.
Okay. Beta, next question now. Beta, figure shows solar cells that use radiation from the sun to generate electricity. State the name of the process which releases energy in the sun. Beta, what process releases energy in the sun?
Sir,
Sir,
radiation.
fusion.
No, energy is radiated. Okay, it
Yes.
travels, it is radiated, but what process releases energy in the sun?
Sir, fusion.
Fusion. Ji beta, beta, you should remember that actually in sun nuclear reactions take place, right? When we discuss the nuclear energy, okay, we discuss in power station and in atomic bombs, nuclear energy is used. Beta, also another example you should remember that the beta energy released in the sun is by a nuclear reaction which is called nuclear fusion. Okay, so it's a nuclear. Clear beta? Because
Yes.
remember that that's important point, okay? And it's also repeatedly asked question in paper 2 as well. So remember that in the sun, energy is released by nuclear fusion. And beta fusion means what? Joining together. So what
Uh,
happens? A
Sir,
reaction takes
two
place in the
large
sun.
nuclei of hydrogen atoms, they join together to make a helium nucleus.
Shabash. Beta,
Change
this
it.
is an example. Simply, fusion is joining of large, smaller atoms to form a large atom. So in fusion, what happens, beta? Smaller nuclei join, okay, or combine to form larger nuclei. Okay, understand, beta? So, beta, what happens in fusion? Small nuclei small nuclei, beta, are you getting it or not? Nuclei join together.
To make a large nucleus.
G beta. Together to make large nuclei or nucleus, you can say. Means if you are defining generally, so you can say nucleus or nuclei. Okay, beta. In fusion, smaller nuclei join together to form larger nucleus. In fission, beta, large nucleus splits into
Are spread.
smaller nuclei. Okay, beta. So this is the difference between fusion and fission. Beta, getting my point or not?
Yes, sir.
Okay. Now, beta, apart from the solar cell, there are other energy sources used on Earth for which from which the radiation from the sun is the source. State the name of one of these energy resources and explain whether it is a renewable.
Sir, wind energy, and it is renewable because
You
it
can
moves.
write wind energy, wave energy, fossil fuels, any whatever you write. Then you have to tell whether it's a renewable or non-renewable. So, beta, what are we gonna write?
Wind, sir.
Wind. Okay, beta, wind.
Or geothermal.
जी बेटा
Geothermal.
बेटा geothermal, you remember I told you beta there are only except three energy sources. The sun is the primary source for all the energy sources, and you know what those energy sources were? Geothermal,
Sir,
tidal, and
tidal,
nuclear.
geothermal.
So how can you write geothermal here when they say each for which the radiation from the sun is the source? For geothermal, sun is not the source of energy beta. For geothermal, nuclear and tidal. Okay beta. So beta, wind energy, we can write wind energy. Shabash. Wind energy. And beta,
It is
wind
renewable.
energy. It is renewable or non-renewable?
Renewable, sir.
And
Renewable.
beta, why it is renewable?
Sir, because it won't run out.
Yes, because beta, wind energy.
Will not run out.
First of all, you have to tell it's renewable. It is renewable as it will not run out because beta it is constantly being replaced. Right beta? Right beta? Beta, can you hear me?
Yes, sir, we can hear you.
जी बेटा Beta, because it will not run. Beta, actually my screen got stuck and I'm unable to write. Okay, my pen is not working. So you can complete it yourself, right?
Okay, sir.
Okay, sir.
Done, beta?
Yes.
Beta, actually my screen is stuck. I am unable to do anything. Okay, next beta, state the two advantages of using solar cells to generate electricity. Can anyone tell the advantages of using solar cells to generate electricity?
Sir, it is renewable and for free.
It is renewable. Okay, Shabash.
Yes.
And
It can be built anywhere.
Sir, it doesn't create any pollution.
yes, beta, one advantage you can write, it does not cause pollution, right? And any advantage?
It is
It is
So
renewable.
it's cheap to maintain.
Yes, it's low cost maintenance, so you can write that.
yes, sir. And the disadvantage is it is not available every time, like not at night, and it is
Yes,
very expensive to build.
Shabash, Shabash beta, and
It is expensive to build.
yes, initial cost you can say is high or beta, but you can also say it takes up a lot of space, right? Right, beta?
Yes, sir.
Beta, got it or not?
Yes, sir.
Beta, actually my screen is not working. I'm even unable to scroll down to the next question.
So you can restart here.
I think I may have to beta restart it, so that will take a moment.
Yes, sir.
So what is the next question, beta? We can discuss that like
So you can restart. We have 5 minutes. It's low.
that's what I'm
You can see now.
saying.
Sir, we have still 5 minutes.
Okay, beta. Let me try. Let me fix it.
Sir, you are disconnected. We cannot hear anything. Sir, we can't hear anything.
Assalamualaikum, beta.
Walaikum Assalam.
Sir, we can hear you from no.
Ji, beta. Now I'm back. Let me share that worksheet we were doing. So, beta, we were doing question number 2. Okay. We discussed advantages and disadvantages as well, right or wrong? Let's better do the
Right,
next.
sir.
Let's do the next question. Okay. So, beta, the question says figure shows an oil tank that has a rectangular base of dimensions 2.4 meter by 1.5 meter. Okay. So The tank is filled with oil of density 850 kilogram per cubic meter. Okay. Now, beta, calculate the pressure exerted by the oil on the base of the tank. Beta, how
Sir,
we
pressure
calculate the
is
pressure? Liquid
rho
pressure?
GH. Rho G.
G.
So 850
Rho
into 10 into 1.5.
G. So, beta, density of the oil is 850 kilogram per cubic meter. Value of G is 10 Newton per kilogram or 10 meter per second square. H is depth of the oil is 1.5 meter. Beta, if you just multiply these all, what do you get?
So 12,750.
12,750
750 pascals.
Pascal. 12,750 pascals, right, beta?
Yes, sir.
Now, beta, the force exerted by the oil on the base of the tank.
Sir, we
Beta,
realize the formula pressure is equals to force over area. Area is given above
so
and
beta, we have to calculate force. So force is equal to pressure times
area.
area, right? Pressure we just discussed, we have calculated like what is the pressure. So it's 12,750 times what is the area. Beta, area of the base of the tank is,
Sir,
we are
two,
given the length and width, and you know how we can find the area
so
of a rectangle,
2.5
length times width. So we will find the area with this 1.5 times 2.4, right? So beta, what will be the answer if you do this?
sir, 45,900.
Ji beta, 45,000 and
900 newtons.
45,900 or what?
Yes, sir, 900 newtons.
45,000.
45,900.
Okay, 45,900 Newton. Beta, is it clear to everyone?
Yes, sir.
Yes, sir. Time is up, sir.
Okay, okay, fine, beta. So, beta, rest of the worksheet we will do inshallah in our next class. Okay, beta.
Okay, sir.
Okay, sir.
Allah Hafiz, beta. Have a nice weekend. Allah Hafiz.
Allah Hafiz, sir.
Love it, sir.